This is the assignment in the course Mobile Robots and Manipulators. In this assignment, I had to choose 6 different locations and calculate which points can be reached from each location. To do that, I had to perform some inverse kinematics calculation. Then, after I made the calculations, I had to rank the points in the table here, from the most points reachable to the least points reachable. In order to perform the calculations, I used the following library in the virtual machine. The library called RVC tool, and first I had to load the model. So the robot is Puma, so I used Puma equals models dot dh dot Puma 560, which this is the type of the robot. Now, when I set the model, I choose the base of the robot. And from there, I can calculate the points. So I use the command puma.base equals SE3, which is an homogeneous transformation function, on the base, which is 3.5, 3.5, and 0. Now the base is set, and I'm counting the nominal values of the joints. So Qn equals puma.qn, which is the nominal values of the joints. Now I will determine the end effector length, which is 150 millimeters. So end effector length equals 0.15, which is 150 millimeters. Now I want to determine the nominal position of the end effector. So I'm performing a forward kinematics to determine the max location of the end effector on the nominal joints, which is Qn. Now I want my robot end effector to be facing downwards. So I'm saying that T nominal equals T nominal, which is the position, multiplied by the translation on the z-axis, that it will face only downwards. After that, when the end effector is set downwards, I will choose the desired point. So now desired point is the point I want to perform the inverse kinematics on. So the point I'm choosing is point number 5, because the base is 3.5, 3.5, which is here, and I want to see if it reaches this point. So it's 3255, 3525, and 0351. So I'm setting the variable. Now I'm performing the inverse kinematics. So sol, which is solution, equals puma.ikine, which is the inverse kinematics, underscore A, which is the analytical solution, on the desired point. And by that, I can see if the robot can reach or can't reach the point. Here I can see that it reached this point. Now, if I want to test another point, I'm just going to the desired point and changing the values. With that, I could perform all points and see that this is the highest rank. And I set the robot in this location. Then I chose the second robot, which is in the point 4, 0.5, and I saw that the distance is 3.04 meters, and by that I can know that they can't collide because it's above the maximum joint values. Thank you very much for watching.